we would have discussed the combination reaction.
Yes,
Yes.
ma'am. We have
And then we discussed the decomposition reactions,
decomposition.
right? And
Yeah.
in the decomposition also, we must have
Thermal
discussed
decomposition.
yes, thermal decomposition, and then the electrolytic
And
decomposition, that is called as electrolysis, and the
that's just,
photolytic decomposition, that is called as photolysis, right? That has been
yes,
discussed.
ma'am. Yeah.
Fine. Any problem till here?
No, ma'am.
Any problem till here? No, fine.
No, no.
Also, we discussed the nature of the chemical reactions, whether it could be a endothermic or an exothermic reaction based on the
Exothermic,
overall
yeah.
energy which is greater, either supplied or released. Yes, fine, good. Very. Now, tell me one thing. We have discussed all of this. Any confusion till here? Any confusion?
No, ma'am.
I hope you went through the NCERT like for this part.
Yes, ma'am. Yeah.
Fine. You must fine. Very good. Now, very quickly, I would want to remind you of one thing because I'm not very sure did I tell you that in the last turn or not. That all the combination reactions generally, I'm using the term generally, not always, but mostly are exothermic in nature.
Exothermic, yeah.
Yes, very good.
Yeah.
And mostly all the decomposition reactions, not all, but some, I mean mostly are endothermic in nature, right?
Yes.
Very good. Now, if I ask you, can you give me one example of a combination reaction which is endothermic in nature? Of a combination reaction which is endothermic in nature. Basically, I have a question for you and please try to attempt. Okay. I'm writing it for you. So the question is, we'll have 4 options. You will have to identify the reaction which is endothermic in nature. Correct? I'm writing the options here. Okay. CO2 gaseous. So this is the first part. The second part. Fine. So these are the 4 options that are given to you. Can you please identify the reaction which would be endothermic in nature? Endothermic. You have understood the question?
Yes, ma'am.
Fine. Let's try to understand this. See, if I ask you all these 4 reactions, what type of chemical reactions do they seem to be?
The first one seems to be a combination. The second one is also combination. The third one as well. The fourth one, decomposition.
Okay, fine. Is fourth one a decomposition reaction? Okay, fine. Let's just separate that out. It seems to be a combination reaction. Fine. Let's assume all 4 of them are decomposition reaction. Combination reactions. Fine. Now, if I ask you to identify the reaction, now, first of all, if they are all the combination reactions, right, it would appear that all of them should be exothermic in nature, right?
Yes,
Now,
ma'am.
the question is saying, even all of them are combination reactions, you need to identify the one which is endothermic in nature. So that is clearly a factual data, a known data, that a type of chemical reaction that would be endothermic, combination reaction that would be endothermic, and the answer is this. Okay. Nitrogen plus oxygen to give you the nitric oxide. But this compound is the nitric oxide. Okay. Not nitrogen dioxide, not nitrous oxide. This is nitric oxide. If you want to write it, please quickly write this down. That, although this is a combination reaction, but endothermic in nature. Fine. I have one more question for you. Quickly write it, then we'll discuss that question. I should write the name here, nitric oxide.
Done, ma'am.
Done? You have understood this? Okay.
Yes, ma'am.
Fine. Now, so we have electrolysis. Any problem in the electrolysis part? The oxygen is found on what electrode? Cathode or anode?
Anode. Anode.
Positively charged or negatively charged? What's the
Positive,
nature of that?
positive.
Wonderful. What's the ratio of hydrogen to oxygen?
2:1.
And how do we know that?
With the
Achha,
number of
why?
molecules of hydrogen and
Okay.
oxygen.
Why is the amount of hydrogen formed is double to the amount of oxygen formed? Why? Because in a balanced chemical equation of the decomposition of water, we get two, this
Molecules of
molecules of
hydrogen and
hydrogen
one
gas.
molecule of oxygen.
Yes, fine. Okay. And if you want to talk this in terms of moles, that will be even better. We get 2 moles of hydrogen and we get 1 mole of oxygen.
One
I
mole of
think you must be
oxygen.
aware of the concept of mole. Okay,
Mm,
fine. Coming on to the next topic. The third type of chemical reaction that we have, the third type of chemical reaction is the displacement reaction. Right? The displacement reaction. Now, first of all, this displacement reaction is based on the metal reactivity series. You are aware of the metal reactivity series?
Yes, ma'am.
Fine. So basically metals are arranged in the order of the decreasing reactivity. Yes. And which is the more reactive, most reactive? Dash. Yeah. No worries. Fine. See what really happens in this. What happens in this type of chemical reaction, beta? The more reactive metal displaces the less reactive metal from where? Alpha beta from where? Hmm. From? Any idea?
From
From
its
its,
salt solution.
yes, aqueous salt solution. Very good. Now, first, quickly understand what do we mean by aqueous salt solution? What do we mean by this? Aqueous means, see, I've already told you this, I think, in the last one when we were discussing the chemical equation. Aqueous refers to water. Okay. Solution means mixing of two things, right? So, what is being mixed here? Water and the
And
salt.
salt.
Salt of what? Salt of?
Or
Salt of?
salt of the metal.
Wonderful. Very good. Salt of the metal. And you must be knowing what a salt is. Positive and negative
Negative.
species combined together, except hydrogen H plus and the OH minus, that is a salt. So let's say we have a salt of copper. Can I write Cu, which is positively charged? And then we have sulfate, which is negatively charged. Is this the salt of copper?
Yes, ma'am.
Yes. And what's the name of this? Copper sulfate. Okay.
Copper
Copper sulfate. And if I write it like this will become
sulfate.
nothing but aqueous salt solution of copper. Okay. Wonderful. Now let's say we are seeing iron, which is a more reactive
Yes.
metal than copper. Okay. So iron will displace copper from copper's aqueous salt solution. From its aqueous salt solution means the aqueous salt solution of the less reactive metal. Is it clear? What will happen here? So always remember, when we are writing a displacement reaction, be mindful that the less reactive metal and the salt of the less reactive metal should be in the aqueous form. Very important. Okay. It should be in the aqueous form. Clear? Right. Then if
Yes.
iron will displace copper, what will it form? What will be the products here? Will it be
Uh,
ferrous sulfate?
ferrous sulfate plus copper.
Now quickly tell me the state of ferrous sulfate here. What will be the physical state of copper, ferrous sulfate here?
Aqueous.
Wonderful. And copper? Hmm.
Solid.
Wonderful. Excellent. So this is an example of a displacement reaction taking place. Clear? Now, quickly I would want to tell you something. The color of copper sulfate solution, beta, aqueous solution is blue. Okay? Aqueous. and the color of ferrous sulfate aqueous solution, okay, is towards greenish. Clear? Therefore, when this reaction will take place, the color of the solution will change from blue to that of green. Done?
Yes, ma'am.
Done? Fine. If I give you this question, if I give you something like this, zinc sulfate. Tell me the product quickly.
Zinc sulfate plus iron.
Will there be any change in the reaction? Will anything be formed in the reaction, beta?
Yeah, there will be formation like zinc sulfate and iron will be formed.
So, but it's already there. Zinc sulfate is there in the reaction.
Oh, sorry, ferrous sulfate and zinc. But I don't think so. Iron can displace zinc because zinc is
Wonderful.
more reactive.
Exactly. So here no reaction will proceed. It will be there as it is. Okay. Wonderful. So I'm quickly coming back to the NCERT. We have to discuss one point there. If you have your NCERT, please open it. Fine. So we have a displacement reaction, activity 1.9. Okay. So we take 3 iron nails. That's fine. That's not a concern. We will do this. What happens, Arfa? Let's see this situation. Let's say we have a beaker, okay, and that was blue in color. Okay, why was it blue in color? Because it had copper sulfate solution. Clear? Fine. We had a nail which was silver in color. Fine. Basically, a proper new nail. Fine. Now, what will happen? As soon as we dip this nail in this beaker, fine, what do we observe? We observe two things. The color of the beaker, of the solution in the beaker changes to green. Okay, like very light green. It will not be a very prominent green color. Okay. And then the nail changes to some brownish color. Why? Why does this happen?
Because iron is displacing copper and the color changes.
Sorry, iron is displacing copper and the color changes. Very good. That's fine. The green color of the solution will be because of that. Wonderful. So ferrous sulfate is formed, right? That is what you were saying? Fine. My
Yeah.
question is, why does the color of the nail changes? There's no reaction happening on the nail.
Is it because of this rusting?
Where is oxygen present there? And
No, it's
rusting is a
not.
very slow process, right?
Mm,
It's not
yeah.
that fast. See, what will happen, beta? We just now understood this equation, right? This copper
Yeah.
will be, like given out in the solid form, okay? Therefore, this will get deposited on the nail. Okay, this copper will get
Mhm.
deposited on the nail, and iron from the nail is participating in the reaction to form ferrous sulfate. Are you getting it?
Yeah.
Therefore, the nail will give out iron, and therefore copper will get deposited on the iron, on the nail in the solid form. Therefore, the nail will acquire the color of copper, which is slightly brownish. I hope that is understood.
Yes,
See,
ma'am.
this is the color of the nail, and that is the color of copper. Clear, beta? This is an
Yes, ma'am.
important point. Fine. Any confusion in this?
No, ma'am.
Fine. So in this case also, you can see the examples. Zinc, which is in the solid form, displaces copper from its aqueous solution, that is copper sulfate, and we get zinc sulfate. Clear? Then also lead, copper chloride, so we get lead chloride, and we get copper in the solid form. Okay. See, this is just, they have just taken the example of copper here. We might take any different examples of different metals, and therefore we'll get the same reaction. Is it okay? Okay.
Yes, ma'am.
Fine. Now, Arfan, remind me of one thing, beta. Did we discuss this activity 1.8 in the last one?
No, ma'am. You just discuss electrolysis. No, we
Okay,
did.
we
We
just
did. We did it. We did. We did. We did. We did.
okay. No worries.
It
So
is.
I told you why does the color that is eventually that was initially silver chloride changes to grayish color, which was white changes to grayish color. Yes.
Yeah,
And why was that?
because of the exposing of sunlight due to fertilizers.
Then what does it happen? What happens there after photolysis that the color changes? No worries. I'll quickly repeat it here. See, AgCl, that is silver chloride. Okay, not AgCl, 2 AgCl. Okay, silver chloride. Basically, it's a white powder. Okay.
Mm-hmm.
And when it is exposed to sun, so basically photolysis will happen here. And during the photolysis reaction, what will happen? It will get decomposed into silver, that is 2Ag, silver elemental form. Are you able to understand this? This is the elemental form. Okay. This is again the elemental form. Okay. Now this silver will basically give the color that is grayish color. Okay. Therefore, the powder will appear to be of this color from white powder. Is it clear? See, silver chloride turns gray in sunlight to form silver metal. Elemental silver means what? It's a silver metal. Okay.
Yes, ma'am.
I think there is some confusion. Is there?
No. I'm done.
Fine. In the similar manner, we will have silver bromide, which will get decomposed into silver metal and bromine, and in the presence of sunlight. And see the above reactions, which is the decomposition of silver chloride and of silver bromide, are used in the black and white photography. So this might be asked in the question form. What kind of reactions are used in the white and hello? Yeah, black and white photography. So the answer would be, first of all, photoelectric decomposition reactions and that of silver chloride and silver bromide. Clear, beta?
Yes, teacher.
Right. And I think we have also discussed this. I told you this, I think. 2 grams of barium hydroxide and 1 gram of ammonium chloride. Yes, I think we have discussed this. What kind of reaction
Yes,
was
ma'am.
this? Endo or exo?
Exo.
This was, uh-huh. This was endo, huh? We discussed this.
Oh.
Okay, fine. No worries. Should we start the next, that is double displacement reaction?
Yes, ma'am.
Fine. And the fourth type of reaction, double displacement reaction. Now, so that is also clear. Like here, displacement is taking place, but double times. Okay, that is 2 times. How does that happen? Let's see. You know what is neutralization reaction? You must have like learned this neutralization reaction. Acid and a base reacting together. Fine. I will take that example here. As acid, HCl is an acid. Okay. HCl is an acid, and only it is an acid when it is in the aqueous form. No worries. Then this is a base. This is also basic when it is in the aqueous form. Fine. And a neutralization reaction, what does it give you? What does it give you? Does it give the salt? So here in this case, it will be NaCl, yes, and H2O and water. This is nothing but a simple neutralization reaction. Yes, Arko? No problem in this? Fine. Let's try to understand how are the products formed here. So this in the water dissociates the compound into H plus and Cl minus. Are you getting it? You have already learned this. I think in the second chapter, you must have learned this, that when any compound is there in the water, water will actually help to dissociate that compound wherever possible. Therefore, it will HCl will get decomposed, dissociated into H plus and Cl minus ions. Clear till here? In the
Yes,
similar manner,
ma'am.
NaOH will get decomposed into what? Can you tell me the components here?
Sodium, oxygen, and hydrogen.
No, beta. Na plus and OH minus. Okay.
OH.
Na plus and OH minus, fine. Now, here in the, as soon as they are mixed together, they are in the aqueous forms. Because of the water, the dissociation will take place, fine. Now, what will happen? Exchange of ions will take place. Or in simple words, double displacement is taking place. Things are getting displaced and 2 times. How? See, this Na will bond with this Cl. This Na will bond with this Cl. And this H plus and this OH minus will bond together. Therefore, what is formed here? Can you see NaCl and H2O? H plus plus OH minus gives you H2O. Na plus plus Cl minus gives you NaCl, right? Therefore, these are the products that we get. And how do we get these products? We get these products after the exchange of ions. Simple. Exchange of ions, right? And how does this happen? Because double displacement is taking place. Is that clear?
Yes, ma'am.
Fine. Now, when the double displacement takes place, there are some of the important points here. See, first point, beta, the reactants I already told you, both of them should be in the aqueous form. Both of them should be in the aqueous form. Then only the
Aqueous form.
dissociation will take place, and then only the exchange of ions will take place, right? The products, one of the product that will be formed will be a solid, right? And that is called as a precipitate. That is called as a precipitate, right? And this precipitate will be a solid. In the above example that we just now saw, NaCl will be a solid, right? It will be a salt which will be deposited at the bottom of the container in which the reaction is taking place. Therefore, it will precipitate out. Are you getting it, Beta?
Yes, ma'am.
This will be solid, whereas liquid water will be there in the liquid form as it is. Okay. Therefore, these reactions are also called as precipitation reactions. Fine. So therefore, the exchange of ions will take place. One of the product will be a solid. Why? Because it will be a precipitate and the reactants has to be in the aqueous form. That's it. Precipitation will take place. Fine. Now,
Yes, ma'am.
if you see activity 1.2 in your NCRT, you have your NCRT?
Yes, ma'am.
Yes. Quickly see that activity. That is just an application of this double displacement reaction. Yes. We have lead nitrate. What will be the formula for lead nitrate? Pb, just a second.
PbNO32.
Yes, PbNO32. Okay. Right. PbNO32.
NO3 whole.
Right. Then we have potassium iodide. Clear? Now see, if they are in the aqueous form, the activity says we have to take the solution of lead nitrate. Yes, therefore it is in the aqueous form. We have to take the solution of potassium iodide. See in your book, there is written solution for both of them. Therefore, both of them are in the aqueous form. If they are in the aqueous form, it will get dissociated into Pb plus 2 plus and NO3 minus. Yes, it will get dissociated into K plus and iodide minus. Okay, I minus. Okay, and the exchange of ions will take place something like this. Tell me, is this the correct product? Is this the correct product?
Yeah, it is.
And this is lead iodide.
That
And this is potassium
potassium nitrate.
nitrate. This will be in the solid form. This is the precipitate. This will have yellow color. Okay. It's a precipitate. Whenever I've written solid in these type of reactions, it means it's a precipitate, and this will be again in the aqueous form. Clear?
So the precipitate that is solid is a salt.
Yes. You see, this is also a salt, right? Plus minus.
Yeah.
It's a salt.
Okay.
It's a salt. Okay. Here also it's a salt. Plus minus ions together.
Okay.
See, in the above reaction, if you're getting confused, there I gave you an example of a neutralization reaction. In
Yeah,
which
yeah.
one was an acid, one was a base. Therefore, they react together to give you a salt. Okay. Here, if you see potassium, lead nitrate, it's a salt. Potassium iodide, that's a salt. The exchange of ions together, and they again give you a different kind of salt. That's any confusion in this, beta? So through this reaction also you can see a chemical changes taking place, and how will you identify that? So from a beaker which was white, both of them initially white colored solutions will eventually give you a yellow solid. That's a precipitate, and that is lead iodide. Fine. Now coming to a good, that's the most important topic, that is the redox reaction. First, tell me how much do you know about a redox reaction?
Redox reaction is basically oxidation and reduction simultaneously taking place.
Good. Good. What is oxidation and what is reduction? Any idea?
Oxidation is the removal of hydrogen, addition of oxygen, and losing of electrons.
Okay, good, very good. Then reduction.
Reduction is the removal of oxygen, addition of hydrogen, and gaining of electrons. Is the opposite of oxidation.
Wonderful. Fine. So let's try to quickly understand some of the points here. Redox reaction is a combination of two types of reactions. One is an oxidation, as you rightly said, Beta. Oxidation, and the other is reduction.
Reduction.
Okay. Basically, oxidation, oxygen is added, that's fine. Okay. So these are some of the characteristics. Oxygen, oxygen added, hydrogen removed. Okay, that's it. You know that. Electrons are lost or gained?
Lose.
Lost. Okay, well. Reduction, electrons are
Gain.
gained. Wonderful. Right? Now see. If I give you a very simple question here, just a second. Let's say I have this and this. Let's say. Okay, I will get this and I will get this. What is happening here?
Here, lead oxide will go under reduction,
Lead
and
oxide will go under.
reduction,
Okay. Then
and carbon will go under oxidation.
okay. Carbon will undergo oxidation. That's what you are saying? Fine.
Yeah,
So therefore, if you say lead changes to, right? This is reduction, as you said, and this is oxidation. And that is
oxidation.
very clear by simple removal of oxygen and gain of oxygen, right? This is a simple
Gain.
clear-cut redox reaction. Because two of them are happening together simultaneously, therefore it's a redox reaction. Clear? Fine. Now if I ask you, what is oxidizing agent? What is
Oxidizing
reduced?
agent. Yeah, oxidizing agent is the one that have gone under reduction.
That has gone under reduction. Fine.
Reduction.
Basically, the agent which is causing oxidation, right? And
Yeah,
itself is getting reduced. Itself
reduced.
is getting reduced. Wonderful.
Reduced.
Reducing agent, which is causing
That have gone under
reduction,
oxidation.
itself is causing getting oxidized, right?
Yeah.
Clear? Fine. In the above example, which one is the oxidizing agent and which one is the reducing agent? Just a second.
Oh, this one. Okay.
Yes. Which one is the oxidizing agent? Which one is the reducing agent? Yes, beta.
Oxidizing agent is lead,
Mm-hmm.
and reducing agent is carbon dioxide.
Fine. See, that's the point here. Oxidizing agent. First of all, understand that here lead ox. Just a second. Saad, are you there in the class? Beta, why did you not tell me that? I did not know that you were in the class and you also did not turn on the camera, huh?
Ma'am, I am not at home, so I can't open my camera right now.
Fine. Are you understanding whatever we are discussing here?
Yes, I will see the lecture again because I
Okay.
came late.
Okay. Fine. Fine. Yes. Arfa and Saad, both of you. So Arfa, see here, beta. Here, lead oxide. Initially, the compound was lead oxide, okay? And then it changed to lead. Clear? Here, initially it was carbon, and then it changed to carbon monoxide. Fine. See, it is lead oxide which is getting reduced to lead. It is lead oxide which is getting reduced to lead. Therefore, the oxidizing agent is lead oxide. Therefore, the oxidizing agent is lead
Lead oxide.
oxide. And the reducing agent is carbon. Clear? And carbon is getting oxidized to CO.
Carbon
Okay?
dioxide.
So it was just the carbon atom which gets oxidized to CO. I hope you are able to understand the point that I'm trying to tell you.
Yes.
Okay. Clearly, one more example here very quickly. Let's say beta we have copper. Okay. Then we add O2 here. What is happening here? Can you tell me, is any oxidation reduction taking place here?
Only. Oh, there is nothing.
Huh?
There's nothing. No, it is. Oxidation is taking place.
Oxidation. Let's give you one more example. Let's say we have this, the same. Okay. And then we get copper plus we get water. What is happening here, beta?
Here, redox
Reduction.
reaction is taking place.
Redox is
Both.
taking place. Wonderful. Yeah. What is getting reduced? What is getting oxidized? Can you quickly tell me that?
Reduce or copper oxide is getting reduced.
Two.
And to copper.
Wonderful. Very good. Okay. Then
And then
Hydrogen is getting
hydrogen is
oxidized
getting
to?
oxidized to water.
Wonderful. Now, what is the reducing agent here?
Reducing agent is copper oxide.
Reducing. The one
Oh,
which
oh
is
wait,
itself getting oxidized, huh?
oxidized. Yeah, hydrogen.
Hydrogen. Which one is
Oxidized
the
agent.
oxidizing agent?
Copper oxide.
Wonderful. Any problem in this, bache? Any problem?
And
See. Now I'm coming to a bit, these are very simple. You can see that and you can clearly tell that which one is getting oxidized and which one is getting reduced. Okay. But there are some equations in which there is no gain of oxygen, there is no removal of hydrogen and things like this. Fine. And you need to find out whether the loss of electrons is taking place or whether the gain of electrons is taking place. And based on that, you need to identify whether it's whether it's oxidation, reduction, or both redox. Fine. And for that,
yes,
there is something that you need to understand, and I will quickly try to explain you that in short. That is oxidation number. Oxidation number. Yeah, something like this. Now, if I try to explain you that, what is this? Let's see. We have hydrogen, we have chlorine. Just try to understand it, okay? We have hydrogen and we have chlorine. Atoms, fine. Atom of hydrogen, atom of chlorine, fine. Now, hydrogen had to bond. Hydrogen lost one electron here and chlorine gained one electron here, right? Hydrogen lost one electron here, chlorine gained one electron here. Therefore, they will form a bond together that will be HCl. Are you getting it?
HCl.
It
Yeah,
became H plus, it became Cl, just to understand. And therefore, HCl will be formed. Clear? Now, when HCl is being formed, what is happening? H plus, that is hydrogen, was gaining charge of plus 1. Therefore, it was losing one electron. Clear? Cl was gaining a charge of minus 1. Therefore, it was gaining one electron. Clear? Fine. Now, I say this is Cl2. Now, there is no gain or loss of electron happening as such, right? Cl is there as it is. Chlorine atoms are there. Are you getting it? Therefore, there is no gain or loss of electrons. Therefore, no charge. Do you understand this? Do you understand this? So whenever the atoms of the elements react together, whenever the atoms of the elements react together and they form a compound, each atom of the element develops some charge on it, right? And that charge is because of the gaining or the losing of electrons. Clear? And that charge on that particular atom in that compound, in a particular compound, is referred to as the oxidation number of that atom or of that element in that compound. Clear? Example, in the HCl, which is a compound, H hydrogen is having a charge of plus 1 in a compound that is HCl. Right? Is there any distraction, Alpha?
no.
Hmm. I hope so, no, huh? Let's see this. This is manganese oxide, MnO2. Clear? MnO2. How do I know what charge is currently there on manganese? What's the atom here? That's manganese. Clear? What's the atom here? That's manganese. If I want to know,
Manganese.
identify the charge on manganese here, beta, how many oxygen atoms are attached to this? 2, something like this. Yes. Each oxygen atom will give a charge of 2 minus 2 minus, right? Therefore, together, does it become minus 4? Don't you think manganese will have to have a charge of plus 4?
Yeah.
Yeah. Are you getting it that way? Right?
Yes. Yes.
Cl, hydrogen was attached to one Cl, right? This gives a charge of minus 1. Therefore,
Minus
hydrogen will have to have a charge of plus 1,
plus one.
right? Are you getting this?
Yeah.
Therefore, so write it in your own words. Write it in your own words. What do we mean by the oxidation number? Try to write it in your own words. Then obviously I'm here to tell you anything. Done, beta? Done, Alpha?
Ma'am, I'm only getting that like any two elements gain or lose electron in a
Right.
reaction.
Fine. I'm giving it to you again. You might write it again. Okay. See, any element in a compound, has a particular charge in that compound, because of the gaining or the losing of electrons. Simple.
In that compound.
Because of the gaining or the losing of electrons. This is not a proper definition. This is just to explain you, okay, so that you are able to understand it. And that charge is called as the oxidation number. That charge is called as the oxidation number of, write it, of that element in that compound. Of that element in that compound. Because see, it has to be very specific. Are you getting it? It has to be very specific. Based on the compound that the element is forming, it will have different charges. Fine.
Yes.
Yes. And write one important point. The elemental form always has an oxidation number 0. The elemental form always have oxidation number
The
0.
elemental form
Always has an oxidation number 0. See, that should be very clear to you. Why? Because see, there's no gaining or losing of electrons taking place there. There's no reaction there. Okay, that you have understood, beta. If I say
Yes,
this, beta, see, this is silver. This is a silver metal. What's the oxidation number here of this silver? It's 0. It's in the elemental form.
yeah.
It's silver metal here, right? No bonding has taken place. Therefore, no losing or the gaining of electrons. Therefore, the oxidation number is 0. But if I write it like this, just assume. If I write it like this, AgCl2. Acha, leave this. If I write it in two forms, you will tell me that. Assuming I write it like this, and then I write it like this. Clear? What will be the charge on silver here? Oxidation number of silver. In the first case, beta, silver is bonded to one chlorine atom, and that's -1.
Yeah.
Therefore, silver will have to have
So
a charge
the
of +1.
positive one. And then in silver oxide, oxygen has 2, makes it one. Yeah, it makes it -4, and then the
Very good.
silver will
Wonderful.
have positive.
Clear? Now, I want to give you one point here, which is very important. Let's say, beta, this thing. I have this HCl. Clear? I have this HCl. If I ask you, what's the charge on a hydrogen here? You will say +1. You will say +1 that because Cl has a charge of -1. Right?
Yeah.
But if I ask you here, what's the charge on H? What will you say? The oxidation number of hydrogen in 4 molecules of HCl. What will you say?
Five.
How 5?
Will we add it?
See, no worries. See. Here, one hydrogen atom, if there's one molecule like this, beta, one hydrogen atom has an oxidation number of +1. Therefore, when there are 4 molecules of HCl, there will be 4 atoms of hydrogen. Therefore, total will be +4. That's it.
Same.
Okay. You have understood the concept. If I say, what's the charge on one hydrogen atom? Oxidation number of hydrogen atom?
+1.
How +1? So there are 2 hydrogen atoms attached to one oxygen atom. Therefore, each will have +1. Very good. Clear? Each will have +1. But if I ask you for H2, what will that be? +2. That's clear because there are 2 hydrogen atoms. Have you understood this, beta?
Yes, ma'am.
Wonderful. Now, the main point, oxidation number increases in a chemical reaction. Element or a compound, the matter, therefore its oxidation. I will tell you with examples. oxidation number decreases. In a chemical reaction, it's reduction. Fine.
And ma'am.
Then I will quickly give you one example here. Please try to understand it. Let's say we have zinc oxide plus carbon. That will give you zinc plus carbon, right? Now, see, first of all, if I ask you reduction oxidation, you will be very easily telling this because there's clear-cut, removal and addition of oxygen, right? But if I ask you to see it from a different perspective, that is through the oxidation number, try to calculate it. See, here and here, okay? Carbon, first of all, let's see carbon. It's in the elemental form. Clearly here it will have an oxidation number 0. Now, if you come to zinc in zinc oxide, the oxidation number of zinc in the compound zinc oxide of that element in that compound. Are you getting this? A specific element in a specific compound. Here, zinc is bonded to one oxygen atom. One oxygen atom has a charge of -2. Therefore, here zinc will acquire an oxidation number of +2. Clear, beta?
Yes, ma'am.
Yeah. And if you see on the product side, you will have to calculate it for both the sides, the reactants and the products. Okay. Now, if you see it on the product side, beta, zinc here is in the elemental form, zinc metal form. Yes, therefore it will have an oxidation number 0. Whereas carbon will gain a +2 charge.
+2.
Therefore, for zinc, it is going down, reduced from +2 to 0. Therefore, reduction.
Reduction.
For carbon, it is going from 0 to +2. Therefore,
Oxidation.
oxidation. Is it clear? Yes or no?
Yes, ma'am.
Fine. Quickly, if I give you
Yeah.
one more example, will you be able to do that?
Yes, ma'am.
Tell me what is happening here. Oxidation, reduction, redox, and tell me in the terms of the oxidation number.
That's magnesium, right?
Yeah, yeah. Now you should be
Okay.
really knowing my writing, huh? Just kidding. Fine. Yeah.
Magnesium will go under oxidation. Goes under
Okay,
oxidation.
Fine. How and why?
Because it's gaining electrons here.
Yeah. Can you explain me that in the
Magnesium was
terms?
0 on the reactant side, and then
Yes.
we had +2 charge on the product side.
Wonderful. Wonderful. Okay. That's it. I wanted to just tell you this. Now, one more example I would want to tell you. Acha, see, one very important point, beta. Now, when you have understood oxidation reduction on the basis of the oxidation number, what is oxidation number telling you? It is telling you how many electrons are lost. Because if the electrons are lost, the positive charge will increase. And if the electrons are gained, the negative charge will increase, right? And what is oxidation reduction? The gaining or the losing of electrons. So are you able to
Electrons,
relate
yeah.
the two things? Oxidation number, how is oxidation number related to oxidation and reduction?
Mhm,
Redox is
yes.
what? Simply gaining or the losing of electrons. If electrons are lost, that's oxidation. And if electrons are lost, obviously the positive charge will increase. And if the positive charge increases, therefore, it is oxidation. We have learned this right now.
Oxidation.
Yes.
Yeah.
If the electrons are lost, that's reduction. And if the electrons are lost, definitely the negative charge increases. And that we have seen, it's reduction. Are you able to make sense of that? Wonderful.
Yes,
Excellent.
ma'am. Ma'am,
Very
in
good.
this
Yes.
magnesium oxide, what about the oxygen? Oxygen will not go anything, right? It is like it combines with the magnesium.
See, here if you see, here it was in the elemental form 0. Here it gains a charge of -2. What is happening here?
Oh, then okay.
Simple
Reduction.
in terms of oxidation number, right? I have a very important example. Please try to understand this and then say, okay? What is this? Hmm.
The
Think and
sodium
then answer. Mm-hmm.
gets a positive charge.
Mm-hmm.
Is that?
Sorry? 1 electron. That's 1 electron.
Oh, that one electron is having negative charge.
Yes. Yeah, that I know. What is happening in this reaction?
Sodium goes under oxidation
Mm-hmm. Sodium goes into oxidation. Why?
because it's gaining a positive charge.
Okay. So are you saying that this reaction is a representative is nothing but oxidation reaction, right?
Yeah.
Fine. And you said that here there is, see, you are absolutely right. Let's try to understand this. This is sodium atom. This is sodium atom. This is sodium
Yeah.
ion. And this has a positive charge. So clearly here,
Positive.
loss of electrons has taken place. Now this must be very enough to tell you that here oxidation is taking place. Clear? And we can clearly see it one electron is being lost. Therefore, it is there as a product in the reaction, right? And also, if you see from the other point of view, here the oxidation number is 0, here the oxidation number is plus. It's increasing, therefore it's oxidation. Clear?
Yes, ma'am.
Wonderful. Now let's see one more example. What is this, Veda? What is happening here? Acha, you need time to write? Please write. No worries.
Done, ma'am.
That. This is the second example. Cl plus 1 electron gives you chloride, Cl minus. What is happening here?
Here, reduction takes place.
Reduction. It was 0, it comes to
It
-1,
goes to
right?
-1.
Yeah. Therefore, clear reduction. And also clearly this was the chlorine atom. It gains 1 electron, therefore it becomes chlorine ion. Therefore, it's a clear case of reduction. Right?
Reduction.
Wonderful. Wonderful, Alpha. Now, let's come to the main. This is a reaction. And now tell me what is happening here.
Here, no reaction takes place.
Okay, that's the point. Here, Na is in the elemental form, so oxidation number. Here, chlorine is in the elemental form, therefore oxidation number 0. Here, Na is in the +1 form. Here, chlorine is in the -1 form. Sodium is going from 0 to +1.
+1. And then
Oxidation.
Cl from 0 to
Chlorine
-1.
is going from 0 to -1. Reduction. Are you getting it? And this is nothing. We just separated this one reaction into its two components and we just wrote it above, right? Na will lose 1 electron, therefore it will become Na plus. Chlorine will gain 1 electron, therefore it will become Cl minus, and both of them together will form Na plus Cl minus, right? What is NaCl? Na plus bonds with Cl minus, right? You understood the point here? You are
So here
being,
so the redox reaction will take place
yes,
here.
it's a redox reaction. Clear?
Yes, ma'am.
Any other confusion, beta?
So,
So see
ma'am, they
here,
will ask these kind of questions.
they might ask. See, what I'm trying to tell you here you cannot see any oxygen, hydrogen being lost again.
Yeah.
Then also it's a redox reaction. Clear? See, at your level, most of the questions will be based on the loss or the gain of hydrogen and oxygen. That's it. But at times, if questions like this appear, you should be very aware of, at least be aware of the concepts behind these questions. Clear? Fine. I'm stopping it here for today so that we are not overburdening you. And inshallah, in the next class, so most of the chapter is finished. Just one topic is
Yeah.
left: the effects of redox reaction, the corrosion, and the rancidity. We'll discuss that inshallah in the next class. And after that, we'll try to have some questions. Right? We'll try to go through the NCRT. See, please, after this, go through the NCRT on your own. Try to go through each and every activity, each and every question given in the NCRT and after the chapter. Okay, within the chapter and after the chapter, so that there's no confusion. And after that, inshallah, in the next class, we'll discuss the NCRT, the corrosion and rancidity, NCRT, and then we'll go with some of the questions that I'll have from my side. Clear?
Yes.
Any other problem?
So,
So I'm
ma'am,
stopping
during
it.
oxidation, there will be a positive ion. Positive
during
electron, sorry. Oxidation, it will be a positive electron.
positive electron meaning
You said that oxidation, when it loses, it will have a positive electron.
positive charge, beta. Positive electron.
Yeah, sorry, positive charge.
Yeah. Obviously, it will have a positive charge. See, at times it might be like this. I will tell you this. Let's see this. Okay. I'll give you just one example here. We'll not go into the reaction. Okay. Let's say we had this. Fine. It had a charge of +2, right? And during the reaction, whatever happens in the reaction, magnesium gains a charge of +4. Earlier also it was
+4.
positive. Now also it is positive, but the charge has increased. Are you getting? Therefore, this is clear
Yeah.
cut a case of this.